Today, we're diving into one of Earth's most fundamental and, honestly, most surprising systems, the global water cycle. It's something that governs our weather, shapes the very ground beneath our feet, and connects every single living thing. So let's get into it.
First up, let me ask you something. Just think about the last glass of water you drank. Where do you think it's been? Maybe a local river? Or a passing cloud? Well, what if I told you its journey is billions of years long and connects you to the very beginning of our planet?
Yeah, you heard that right. That exact same water has seen the rise and fall of dinosaurs. It was here for the dawn of human civilization. It's been recycled endlessly in this vast ancient system that connects literally everything that has ever lived on Earth.
So how is a journey like that even possible? Well, it all comes down to one simple, unbreakable rule that governs all the water on our planet. The supply is fixed. You see, on a planetary scale, the Earth's water cycle is what scientists call a closed system. And what that really means is that pretty much no new water ever arrives on Earth and none of it ever leaves. The water we have right now is all the water we've ever had, and it's all the water we're ever going to get. So just think about what that means. The water in your coffee this morning could have once been in a puddle that a T-Rex drank from. It is the ultimate recycling system, constantly moving and changing form from liquid to gas to solid and then right back again, and it's been doing that for eons. Okay, so if the total amount of water is constant, where is it all hanging out? The answer might actually surprise you, because it's not all just flowing in our rivers and lakes. The way Earth's water is divided up is, well, it's pretty staggering. A massive 97% of all the water on the planet is saltwater, locked away in our oceans. That leaves just a tiny 3% as freshwater, and that's the water that's essential for all life on land, including us. But let's zoom in on that little 3% slice of freshwater. Where do you think it is? You might guess rivers and lakes, but here's the shocker. Almost 70% of it is frozen solid in glaciers and ice sheets. Another 30% or so is hidden deep underground as groundwater, and all those familiar rivers and lakes we see on the surface, they account for just 1% of the world's fresh water. It's wild. Now, these huge reservoirs aren't just sitting still. The real magic of the water cycle is how all this water moves between these different stores. So, let's follow the journey and look at the core processes that keep it all flowing. At its heart, the cycle is really driven by four key actions. First, water rises up into the atmosphere as vapor. This is called evapotranspiration. Then, of course, what goes up must come down. That vapor cools, condenses, and falls back to Earth as precipitation. From there, it either soaks into the ground, that's infiltration, or it flows across the surface as runoff, eventually finding its way back to the oceans to start the whole cycle all over again. But what powers this constant, planet-sized machine? I mean, this incredible system doesn't just run on its own. It's actually driven by two incredibly powerful and fundamental forces of nature. And the drivers are perfectly laid out here. On one side, you have the sun's energy. Think of it as the cycle's engine. It provides the heat needed to lift all that water up into the atmosphere. On the other side, you have gravity, which acts as the guide. It's what pulls that water back down to Earth and directs its flow across the land. One lifts it up, the other brings it down. A perfect partnership, really. Okay, so we've got a closed system with a fixed amount of water. Now, that might make you think we should never have to worry about water shortages, right? But it's not quite that simple, and understanding why is absolutely crucial. And here it is. This might be the most important takeaway of all. While the global water cycle is a closed system, water systems on a local level, like, say, your city's river basin, are completely open. This means water is constantly flowing in and out. The amount of rain your region gets isn't some guaranteed thing. It can change dramatically from year to year. And this is why water isn't distributed evenly. It's how one region can face devastating floods, while another is suffering from a crippling drought, all at the same time, while the total amount of water on Earth hasn't changed one bit. And this is exactly where factors like climate change and human water use can really throw a wrench in things, altering those local inputs and outputs and turning a dry spell into a severe water crisis. So this leaves us with the central paradox of water on Earth. Our planet as a whole will never run out of water, but having the right kind of water in the right place at the right time, well, that's not guaranteed at all. And managing that precious, localized supply is without a doubt one of the greatest challenges of our time.